So in the last session, we completed all about object class. So what is the importance of object class, and what are the methods available as what are the methods available as part of the object class? And out of those methods, which are important methods, especially on daily basis, what we can use, or maybe in couple of scenarios point of view, which methods we will use. We taken a discussion. So we had a discussion about toString method first, and then we started discussing about hash code and equals method, and we understood the importance of equals and hash code method with respect to objects comparison. Like it's nothing but comparing the data of an object. So whenever we want to compare data in between the objects, so we have to go with equals and hash code methods overriding. So equals method will compare the content, and hash code method will defines always the unique location at the memory reference, or how many instances has to be maintained at memory level. So that is how we understood the importance of the equals and hash code method. So generally we used to call it as the contract of equals and hash code methods. So we will use these two methods overrid overridden in our classes, especially when we want to eliminate the duplicate objects, and when we want to go for generally sorting point of view. All these times, people will always override the equals and hash code methods based on the requirement perspective. So that is all more important about the object. And one more specialty of object is, the most important feature of object class is it's a superclass of all the classes. It's a global superclass. That means there is no other class on top of object. In this world, whenever we define anything with respect to Java point of view, Java language, either frameworks or whatever you take, everything is always a child of object. So there is no other class beyond the object. So nothing is there in the beyond the object. Everything comes only as part of child of object. Only whether it is a user defined or predefined, whatever you take, it's always part of object child. So that is what we have to remember as part of our object class. Okay. So today the new concept is all about a small topic, but a little bit important also, and good thing also. And let's see what is a typecasting. So typecasting, the concept name is typecasting in Java, typecasting. So what is the point of typecasting? What is a type here? What is a casting here? Let's try to understand here it is. Okay. Simply here data type representing data type, guys. Type means data type. In Java generally, whenever we use a word called as type, means it's all about data type, whether it is a primitive data types, non-primitive data types, whatever it is, it's a data type. And casting is all about converting in this specific case. So data type casting is representing in this case is as nothing but a converting point of view. So that means simply typecasting is a process of converting one data type to another data type. Converting one data type to another data type. So that is what called as typecasting in Java. So it's all about the process of converting one data type to another data type. So one data type to another data type. So what is the point of one data type to another data type? Let's see here. So sometimes in our real-time scenarios point of view, what will happen here it is, assume you got this value, like some reason you got 18.99 something, but you want only some round figured value, or you need this value as an integer value. Assume your logic is expecting only integer value, but you got input as in this format, but your logic is already defined. It is, somehow it is expecting only integer value. You don't want double value. So then what you have to do? And by the time you're already received value like this in the double format. So that means the actual data type is double in this case. And you have to now make sure convert it to integer. Convert it to integer. converted to integer. So that's what calling as typecasting in this case is. Yes, we can do here double to integer, integer to double. Like that, we can convert one data type to another data type. So that means again, here you have to remember two things. I mean, one thing is we know how many data types we have. Primitive data types, how many types of data types. So we know primitive data types and as well as non-primitive. Non-primitive. So with respect to primitive, we can do the typecasting. With respect to non-primitives also, we can do the typecasting. So first, let's take the primitive data types, typecasting with respect to primitive data types, and then we will understand with respect to non-primitives also. Okay. So here, simple guys. It's a very simple and straightforward concept. There is no hidden use cases and all these things. Just very simple and straightforward. So converting one data type to another data type. So now, again, when it comes to primitive data types, yes, example is same thing. So the moment you converted 18.99, something like integer value, assume it is taking a round figure value like natural number point of view 18. So it's all about the process of typecasting. So here, understand, again, there are two things available. Again, there are two types of casting available. So please remember, there is a concept we discussed earlier like called as auto boxing and unboxing. Still, there are so many people used to confuse with auto boxing with typecasting. Still, there are so many people are getting confused with auto boxing is nothing but typecasting. A typecasting is as an auto boxing. No. See, auto boxing, what we discussed in our earlier cases with respect to wrapper classes, it's all about converting your primitive to respective wrapper object. That is what calling as auto boxing and unboxing point of view. It's all about converting your wrapper object to respective primitive value. So this is all comes under the auto boxing and unboxing what we discussed. It's only specific to same data type. Only thing is primitive to wrapper, a wrapper to primitive. But today we are discussing a concept called as typecasting. Typecasting is completely a different concept, something like one data type to another data type, not the same data type. So that's why don't confuse with that concept. Still, there are so many people who used to confuse in between typecasting and auto boxing point of view. The moment we are asking about what is auto boxing, they used to say typecasting sometimes, and sometimes when we are asking typecasting and they are used to say like auto boxing, and sometimes they will say like both are same. So it's not. Okay. So now the typecasting is all about converting one data type to another data types. So here, again, the data type typecasting is done in two ways with respect to primitive data types and as well as non-primitives also. The first one is categorized as implicit casting. So it's called as implicit casting. So what is the point of implicit casting is, or it will be called as sometimes widening also. Widening casting. So what is the point of implicit casting? What is the point of widening casting? Let's understand. And second thing is, one more type is opposite to this, external casting and as well as our explicit casting. And then it is calling as widening, opposite is narrowing. So what is the point of these two types? Let's understand one by one. So if you understood one, then simply opposite to the second one. That's all. So what is the point of implicit casting? What is the point of widening casting? Here it is. Just understand here, and why it is calling as implicit casting also I'll tell you. So the point here it is, why we are calling, what is the point of implicit casting here it is? See, it's all simple. Like for example, I'll take a general example. Okay, so what is my example is? See, how can I say? Yeah, I didn't want to take more into another level point of view. See, assume I have this much space. Okay. allocated for something, and I have one more area, this much space. So that means I have two things here. One is taking this much size, another thing is taking this much size. Now, in this case, assume okay, something A, B, I'll take like this, A, B, whatever it is, A and B. This is what somewhat. Now, in this case, the moment I'm moving to the A to B, so I'm trying to place A into B. Yes, I can do without any. That means what happening in this case is simply in our layman terminology or in our normal terminology, the small space or small object or small thing, so small object placed inside big object, inside big object. So it is easy to fit. So just like small thing into keeping in, assigning back to the big thing. So that is what you did. Okay, fine. And same thing if I taken again, same second scenario point of view, another scenario point of view, opposite to same thing. What it is now again I have A and again I have B. So in this case also again, A is a smaller one and B is a big one. Now by some reason, I'm trying to make putting B into A. Putting B object or putting B into A. What's happening here it is? It's on general point of view I'm trying to say. So what is the problem here it is? So here in a simple terminology, you are keeping small things into big things, big size. Here the big item you are trying to keep into small item. So here what you are doing, you are trying to keep the big thing into small area. So what will happen? That is what typecasting with respect to data types in Java. So that is what we are talking about, impliciting and widening. And explicit in, so sorry, this is called as explicit casting or narrowing casting. So that means, now if I am taking same names, I used to call this as a widening casting. First scenario, widening casting. And the second scenario, I used to call it as a narrowing casting. So explicit casting, so explicit or narrowing casting. So that means what's happening in this case with respect to data types here it is, you know the range of primitives also, especially primitive data types. If I'm opening the primitive, range of primitives, if you see here, primitive data types range in Java, whatever it is. Yeah. So if you observe here, maybe if you take I will take from here. Default values I don't want. Size I want especially. No, we don't have any sizes here. I think they're given here. Yeah. 1 byte, 2 bytes, 4 bytes, 16 bytes. So, yeah, 8 bytes, 64. And float is all about again 8 bytes pointer. Okay, yeah, this is what I want. So if you observe here, the point what integer, for example, I'm taking integer is going to take always the 32-bit size. So that means if I am having a value integer a is equal to, okay, so if I'm taking a value integer a equal to 100, something I take it. Now the moment I assign integer a equal to 100, what is going to happen? It is going to allocate it in 32-bit memory. 32-bit memory. This is what we understood. Now I taken one more variable called as double B equal to a I did. So what I am doing in this case, I am assigning a value to the double. A value to the double. Or you can take long also, whatever it is, data type point of view. So what I am doing here, long. I taken long B equal to A. So here, the moment long B, So A point of view, the memory size is 32-bit memory, and B point of view, the size is 64-bit memory. 64 bits size or memory size, whatever it is. Now, that means what's happening? It's a very small item, 32-bit item size, 32-bit memory size, you are keeping into 64-bit memory. So that means in this case, what's happening? This is what? This is what the point I'm trying to say. So A is having 32-bit item and B is having 64-bit. So that's why there is no problem. You are directly keeping that 32-bit content inside the B level, B reference level. There is no problem. So that's why what you are doing widening the casting. So that means you are in this case what you are doing, A variable value assigning to the B. A data type is integer, B data type is long. Both are two different data types. And what you are doing in this case, this is you are making an implicit casting. So that means you are not doing any extra process. Automatically, internally, Java will take care of, okay, A value into B side. A value will be assigned to the B. So that means with respect to memory point of view, lower value you are keeping inside the upper limit value. That's what I can say in a simple layman terminology point of view. So what's happening in a short summary point of view here, it is small data type to big data type conversion. Small data type to a larger data type conversion. That's what you're doing here. Yes, this is what we can do. Let me open some programming and we'll try to understand. It's a very simple and straightforward case. New Java project, typecasting. So I'm just taking let's take like this. Same as it is, I'll take. Okay, so this is what we did here. So you're keeping A value 100 and you're just keeping into long. So it's just making small data type of A. You are just converted to larger data type to, I mean, actually data type point of view, I can take like integer and your larger data type is all about long. That's what you're doing here it is. So this is called as implicit or widening casting. So if you see the value of B, what will happen? So run as Java application. So you can see B value is 100. So there is no problem in this case. Only thing is the problem comes when you are making larger to small, because it's all memory size issue. What's happened in earlier case? So when you are trying to keep B inside A, actually this is A. In reality, this is A. This is what you maintained as A. Yeah, this is what A. And when you are trying to keep B inside A is smaller one. And you are trying to convert big thing into small thing. So what's happened? You know that. For example, assume when you want to keep some big things in a small area, what we used to do in real time scenarios point of view or in our real life point of view, maybe we will adjust it or we will cut down it. We will cut down it some sides we will adjust it and we'll do some adjustment or whatever it is. So that means what happens in our real life when you are trying to keep some big things into small things, we will maybe we will do some adjustments or we will cut down it into some we will remove extra thing and then we will try to make exactly that item being fitted into the small area. So that means, so what's going to happen? The content losing. So content losing. So that means what's happening here it is, you are going to lose some content. You're making small thing means you are losing something. So that means here in this case, there is no problem because small to big, there is no issue. That's why it's called as implicit or widening. Now, why it is calling narrowing is the big one you are trying to keep into small, big data type to small data type conversion. So that means in this case, internally, what's going to happen is something, a small conversion problem will come, and to overcome that, we have to follow some syntax here. What it is, see here. So it's a very simple when it comes to implicit. So I can say like here, byte can be converted to short, and short can be converted to integer. Arrow marks, if you are observing, short to long point of view, and into to long, and then long and followed by float, and then double, because we know double is the biggest data type in numbers point of view. You can keep in this format. So this is the syntax it will come out. Now, if I'm changing my arrow marks in a reverse direction, then that comes under the narrow casting point of view. So that means, for example, assume I'm trying to keep, even I can make sure like this, double to float, and then long to see, it's whatever it is, just yeah. So this is the order. I mean, I'm just taking as one of the examples. So what you are trying to do in this case, you are trying to convert long data type to integer data type, or short to byte, or double to long, or double to integer. So double size is 64-bit. Integer size is again 32-bit. Short is 2-bit. Sorry, 2 bytes. This is 4 bytes. This is 8 bytes. 16. So like that. So how? So that means bigger data type to. So opposite to this. Larger data type to smaller data type is all about explicit casting and narrowing casting. Narrowing, you're making narrowing. So that's why they given word narrowing. And what is the point of explicit is just understand the issue. I mean, understand the coding, then you will realize what it is. Second scenario, it's all about explicit setting, explicit casting. Okay, let's take one more example. In this case, I'll take dollar, sorry, double dollar price equal to something I taken 88.99. Okay, and integer in rupees, something like that I taken. I mean, don't just, it's all about point of view. And I'm making like this dollar price. Loss in here. So what's happening in this case? You cannot do direct conversion. So it's not happening. No conversion is happening directly. No conversion is happening directly. So why? The reason is what? No conversion is happening directly. The problem here is what? Because you are making larger data type to smaller data type conversion. So you are making larger to smaller. So it's all space issue or maybe memory issue, memory allocation point of view. So that's why you are getting this issue. Now, how to resolve this issue is you have to do some explicit casting. Explicit means something you have to mention here it is. So what is your target in this case? You are making double converted as integer. Converted as integer. Converted as integer. That is what target here it is. Double converted as integer. So in that case, what you have to do is, there is a formula you have to follow in this case. That is, generally what you are doing in this case is, the syntax what you have to follow here, it is target type, okay, of value. Sorry. This braces comes here and then followed by value. This is what you have to follow here, it is. So some extra specification, something extra you are making things here, and explicitly your casting means as a developer, we have to make sure this kind of small setup here, and that's why it is calling as explicit casting. So if you go here, now what I am doing, what is my syntax? I said target type. So what is the target type in this case? Integer. So the moment I said target type integer, so what's happened? See here, the error is gone. So this is what the syntax I given. So here you did the type, okay. Here you did the explicit casting. When you, especially when larger to smaller point of view, this issue will come. Explicit casting. So now print the value of in rupees. What will happen? See, and you can see the value of, so what, 88, but the real value is what, 88.99. So that means in this case what happened? So there is a possibility of losing the data. So there is a possibility of losing the data, truncating the data, whatever it is. So loss of data, nothing but what's happened in this case, truncated data is truncated. So that's what I said right earlier. In our real life also, when you are trying to keep big thing into some small area, what we used to do, we used to cut it down, or some edges we will remove, or something we will make something like it is feasible into that small area with whatever the big one you are having. So we used to do that. Like, so in the professional terminology point of view, they call it as a truncated. Truncated is nothing but it's all simply like just making kind of extra things being eliminated or removed. So that's what truncated. So that's what happened, right? So the actual value is 88.99, and the moment you convert it to integer value, so it converted as 88. So that means in this case, what happened? This .99 or whatever it is got truncated. So you lost some data. In earlier case, you didn't lost anything because it's a big data, obviously. It's a small thing and you are converted to big. So there is no point of losing data in this case. But here it used to happen sometimes, but not all the times. There is a possibility of losing data, but here there is no point of losing data because it's all small to big one. But here bigger to small one, and that too you have to remember the small setup. So that means tomorrow, when you are converting from double to short, what you have to do? So double value being converted to short value. Target is what? Short. So that means you have to make sure like short of value. So that means again, if you are converting integer to short. So in this case, source is integer, target data type is what? Short. That means larger to smaller. So then what you have to do? Again, you have to do this. So short of, in the square, I mean in this parenthesis braces, you have to mention short, and the real value you have to mention here it is. So this is the syntax we have to follow here. So let me take one more example also. So integer age equal to, I given something like 28, whatever it is. Now short, okay, short age 2 equal to something, whatever it is, what it is, age. So what's happened? Again, larger data type to smaller data type. So you are assigning larger value to small data type. So that means you are converting larger value to small value. So then it's not happened directly. You have to do explicit casting, means you have to do this formula. So what is that? Target data type. What is the target data type? Short. the real data type of age, real value 28 available inside the variable called as age variable. And in this case, the target is short. So that means here in the parentheses, you have to define short. Then then Java is going to make sure that value of age variable is okay converted to age2 level or with respect to short data type. Simply integer value converted to short. Yeah, so 28 you got. So this is what called as explicit casting or explicit casting or narrowing. So that's what you are making. You're just bringing narrowing. So that means bigger one into smaller one means narrowing. This is all comes. Previous one is called as implicit casting, widening, nothing but widening. That means you are making small thing into big thing. So that is how we are going to understand this typecasting point of view. Yes, we can do the overall content of conclusion of this concept right now. Here it is. We can convert one data type to another data type, guys. So sometimes your requirements, what will happen now? Sometimes this will happen most of the times. You got somehow assume from the front end, you got value as some reason you got like 28.99. And you have to make sure this value has to be round figure value. You don't want to take the dot values. You have to take only the main value. So that means 28. Then what you have to do? So you received it as nothing but double. So that means you have to make sure this value is considering finally as 28 only. So then what then definitely you will do this one only. This typecasting you will do, that double value you're going to convert it to integer or whatever it is. Simply, then finally you will get only this plain number or natural number and you will use that and you will send it to the database, whatever it is. Like that. So these things will happen in general in our day-to-day applications point of. So now, whatever the discussion we taken as of now, it's all about primitives. It's all about what primitives. But what about the non-primitives? So what about the non-primitives? So I said primitive data type point of view, it's very simple and straightforward. There is nothing to discuss much about it. What about the non-primitive data types? So nothing but, right? String, student, product, order, are any predefined classes. Going further, you will see a lot of predefined classes like exception class and array list class. So many, not even one. There are hundreds, thousands. So these are all etc. 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 Non-primitive data types. Nothing but a class. Simply, I can call it as a class and object. So then what you are going to do with these cases? So in this case, how you are going to deal with the references? So simply, generally, what is the point of non-primitives means? A reference data type. People used to call it as a reference data type. So why means object. We will create object, right? So that is why. Our object is being called as references. So typecasting with references. How you are going to do that? So that means let's understand what is the rules. Some rules you have to remember here always. So in this case also generally we will do same kind of casting only. So but when it comes to non-primitives point of view, when you are making smaller reference, I'll tell you what is the point of smaller. How will you calculate a smaller point of view? I'll tell you. So here's some small extra things we have to take care. Smaller reference to larger reference. See, in previous what happened, it's all about a pure directly values. There is no concept of objects. But remaining all other things comes under the object perspective. Perspective. Like for example, if I take an student, product, order, all these things comes under classes. And for classes, we can create always only objects point of view. So then that is what smaller reference assigning are converted to as a larger reference point of view. So what we are going to call it as is, in this case, it's all called as upcasting. So nothing but implicit casting. Yeah, implicit casting only. Similarly, the second data type is opposite to that. So it is, I can give headings like this. The first one is, in this case, upcasting only. Okay, the second one is just opposite to this. Yeah, sorry. Second one is all about downcasting. Okay, so it's all about again explicit. So generally in interviews, you can tell them like we have two types of typecasting, implicit and explicit. Implicit is nothing but smaller data type to larger data type. Explicit is nothing but larger to small, larger reference to small reference. But when it comes to real values, you know that which is a, I mean, with respect to memory point of view, you used to say like it is a big, it is a small data type, it is a larger data type. How based on the size you are able to see that, say that. But when it comes to the objects point of view, you don't have any particular size. You don't have any particular size. So then how can you say that this is a big object or this is a small object? So here, in this case, with respect to non-primitives point of view, we have to remember always inheritance relation. Inheritance point of view, we used to say smaller or big, nothing but child class versus parent. Child versus parent, nothing but, you know that it's all about what? Subclass versus superclass. So based on that, we can say like this is a child, this is a parent. So this child is nothing but small object, I mean small reference or smaller data type reference. Parent is nothing but larger data type reference. That is how you are going to say with respect to non-primitives point of view. Primitives point of view, you are having direct size and values. You know that it's a fixed size always defined by the Java language. And integer size is always 32-bit memory wherever you go. And long is 64-bit. Double is 64-bit. So it's a predefined size. And values, length, range, everything is predefined. So that's why you can say very clearly which is a small, which is a large. But here, objects point of view, you cannot say like which is a large, which is a big, because you don't have any size specified for an object. Dynamically it will change. But how we are going to say like upcasting and downcasting, implicit casting or explicit casting, here it is. The moment you are having classes and you are taking child versus parent point of view, there is a relationship between those classes inheritance point of view, then only you can do this type of casting. Then only you can do this kind of typecasting. So see here, I'm taking a class called as um, okay, so something like bank application, whatever it is. So integer, whatever it is, you can. It's all variable names and all. I'm not talking much because you know all these things. String name, bank name, or whatever it is, you can take, etc., etc., etc. So the point here it is, you can assume so many variables are there, so many setter getter methods are available, and whatever it is. So it's not the point of discussing about all these details. So in this case, the point here it is, it's a class of bank application. Okay, fine. Now I'll create one more class. I'm creating one more class called as ICICI application. So understand the point. Now again, I created one more Java class called as ICICI application class, something like that. Okay, so in this case, again I taken like string bank name equal to something like ICICI, whatever it is. something. I have some other properties point of view. Assume it is a POJO class point of view. You have a lot of other data variables and etc. etc. Now the point here it is I can create objects for these two classes. Okay, let me show you that one also. I'm taking a separate class. So I'm taking a separate class and I'm saying like type casting with the non-primitives. That means references point of view we are dealing with. And let's understand the point here it is. No. So what you have to understand here, see here. So first I created an object for the bank application. Yes, I can create bank application equal to new bank application. So this is an object. Fine. Now I am creating one more object for the ICICI application equal to new ICICI application. So total two objects I have now. Now I want to convert bank application data type to ICICI data type application. I want to assign it like that. Similarly, vice versa also. Similarly, I want to do same thing, vice versa point of view. Is converted to bank application. So this is what all about we are talking about typecasting, one data type to another data type. Now by default, is it possible or not? Let's understand here it is. Okay. So what I am doing, first take this scenario point of view. So I'm trying to keep the reference of bank application here it is. The reference of bank application here it is. Now what error you are getting? The mismatch cannot convert from bank application to ICC application. So it is saying like you cannot do that. Why? The reason is you don't have any relationship between this ICICI and bank application point of view. So that means as an individual class point of view, so in this case, ICICI and bank application, two classes you derive. So it's a bank application and class and as well as ICICI application class. Both are two individual classes. Both are two individual classes. So the moment I created objects for these two classes in individual point of view, how do I know that this is a small object or this is a small object or this is a big object or this is a big object? How do I know that? I cannot measure it. Because these are all classes and objects. So I cannot say like this is a small one, this is a small one, or this is a big one, or this is a small one. I cannot measure it. I cannot say that. Why? Because both are individual. So now the moment, assume I made some kind of relationship like this. So that's why in earlier case what happened, the conversion, you cannot do the typecasting in this case. So that means in this case, by default, typecasting not allowed. Why? Both are individual. You cannot select which is a big, which is a smaller one with respect to objects point. So that's why typecasting not allowed. But if you take in the same thing again in a format, so if you take in same thing again in a format like this, so if you made a relationship of inheritance, for example, assume ICICI application extended the bank application, extends the bank application. So now I can say which is a small data type, which is a big data type. So in earlier I cannot say because both are individual classes. There is no relation between bank and ICICI classes. So that's why I cannot say this is a small data type or this is a small data type or this is a big data type or this is a big data type. I cannot measure it. I cannot say which is a big, which is a small. But now I can say very clearly which is a small data type, which is a big data type. The reason is I have an inheritance relation. So the moment I have an inheritance relation is nothing but this class became as what child based on my arrow mark. ICICI application inherited the bank application. Nothing but this became as a parent class. So super or parent, whatever it is. Super or parent. Super or parent. Yes. Now I can say this is a larger data type, this is a smaller data type because of the inheritance relation. Now you can do the typecasting again. Typecasting alone. And the point again, understand now same concept again. Now coming back to here, same concept. So one small thing what you have to understand here it is the moment you are doing the typecasting with non-primitive data types, okay, and the casting or the conversion will happen always between child versus parent, parent versus child. That is what one rule you have to remember. You cannot do directly like any data type to another data type directly like that. Simply you cannot do that. So that is why you are getting a error here it is. So it is saying like what is this, what is this? There is no relation. How can you do that like that? So that's why you can't do that directly. Now the moment you made inheritance relation between these two classes, then you can do the typecasting. Now with respect to my example, again, so the moment I'm converting bank application to ICICI application. So that means I'm assigning bank application reference to ICICI application reference. Then it comes under implicit or explicit. So bank is a big one. And that reference you are assigning to the child reference. So that means larger data type reference is assigning to the smaller data type reference. So it comes under the narrowing. So nothing but explicit. Or it comes under the downcasting. You are making down. And that means explicit casting. Explicit casting. And if I take an again same thing, I mean ICICI bank application reference to bank application reference. So then it is called as widening, upcasting, or it used to call as upcasting, or it used to call as implicit casting. Because why small data type to big data type? It's not a big deal. So in this case, it is happened like this. So what happening in this case is bank application is a parent, right? So you are trying to keep parent inside the child or super to subclass. Now in this case, you are keeping child inside the parent. Yes, obviously, right? Parent can hold the child. So, and we remembered one in the polymorphism time I given you one principle also. A parent class can refer child class object. So that is what happening here it is. The parent class can refer the child. Yes, it's a parent, it is a child. So that is what the same principle being applied here it is. So that means whatever the principle we discussed earlier, that is already following downcasting, explicit casting. Sorry. Yeah, just see here. So in this case, this is parent, right? Yeah. Parent, you converted to child. Parent, that means big is larger to small. So that's why narrowing, explicit. So child to parent. So child is assigning to the parent reference. Then again, widening, upcasting or implicit casting, it used to be called as. Now see here, with respect to my point of view, I am making extends bank application based on my explanation. Extends bank application. So understand. Now come back to our program. So what is the principle we know earlier? We have a principle, right? We discussed in the polymorphism type. A superclass reference can hold subclass object. Nothing but what you are doing is, so what is the superclass here? Bank application is the superclass. Okay. And see here, bank application equal to new ICICI application. So that is what, or I can write like this. So let's go like this. I have an object of child class ICICI application ICICI equal to like this. So now what I'm doing, I'm referring this ICICI to here. Yes. So what you did in this case, what you did, this is what small child. So that means you are converting smaller to larger. There is no issue then. Smaller to larger means there is no issue. There is no casting required. So because it's a child, it is a parent. This is a child reference and it is a parent reference. So that means you are making smaller to larger. You are making smaller to larger point of view. So nothing but what you are doing in this case is child pointed to parent. There is no issue. Child can put easily inside the parent. Small thing into big one. Now opposite case point of view, let's understand. Yeah, this is what we did. Step number 1. Now it's all about opposite. So that means I'm trying to put parent inside the child reference. Parent inside the child reference. So see what's going to happen now. Yeah, so it will be called as upcasting. Sorry. And then see, can I do this opposite action? We discussed at that time. So parent referring child is okay, but child referring parent, you can't do that. You can't do that. So let's try that first once, and then we will understand what are. So now I'm creating again one more bank application, bank 2 equal to new bank application. And then I'm taking ICICI reference. ICICI application reference, ICICI app equal to bank. So what you are doing, you cannot do it directly because child can be assigned to the parent, but not like parent assigned back to the child. You can't do that. So now here, if you are making this kind of casting, what's happening? Something is satisfied here. It is. So what? Same thing. You given target type explicit casting. You given target type again here. So that means you are saying like, in case in this bank 2, if there is any object available, you are converted to ICICI application. So see here, I'll do one thing. I'll print first of all sys out of bank application dot get class. So I said the get class is a method from the object, right? So, and I'll print sys out of ICICI app dot get class. So let me execute it. So if you observe here, some exception is coming, runtime point of view, some error is coming. What is exception? You will understand after this concept. So if you observe here, first thing is what happened here. You can do this very easily. So implicit casting, there is no issue. And if you observe here, in the bank application level, which object is really available, guys? So that means what happened in the first point of view here it is. You have child object of ICICI and you taken a reference of bank. So this is the class of, object of ICICI, and the class is also ICICI application class, but you hold it with the parent reference, nothing but bank application. Okay, and you taken a variable name called as bank something like that. And you just had a reference pointing, bank pointed to the real object of ICICI application. So that means in this variable level, what is the real object available? The real object means the real data type, the real class object. What exactly is available internally is ICICI application. So that's why if you observe here, what you got, the moment I printed reference of bank application dot get class, I'm asking the JVM, hey JVM, this parent is pointed to this reference. Can you give me what is the exact class name? What is the exact the object, whatever it is pointed, this reference is pointed to the object, that object being created for which class? Like that, I'm asking the get class name. So then it is internally what it is doing is the moment you are asking the get class name, it is going to the object and it is verifying what is the class name. It is the class name of ICICI application. That's why you got this value. Okay, fine. Now the second point, bank application. Okay, parent object you created, nothing but this is parent object, and you are trying to put parent inside the chain. You are trying to put parent inside the chain. What happened with respect to this point of view? It's okay, but the problem, something you observe here, class cast exception example, bank application cannot be casted to the ICICI application. Bank application cannot be casted to the ICICI application. So why? That means what's happening here, it is or in module of something like that. It is saying like this is not possible. This is not possible directly with respect to parent object putting inside the child is not possible. Parent object. So this scenario is not happening. So that means you can't do. What's happening in this case is we cannot, parent object should not be kept inside the child reference level. That's not possible in Java. That's not possible in Java. Okay. So that's why you got this error. It is saying like I cannot do the typecasting. So let's execute one more time. And it is getting error also at line number 21. So that means which is line number 21, this one. So in this case, the conversion is not possible. Parent to object to child point of view, conversion is not possible. Conversion is not possible. So this point is not possible directly. But here itself, you have one more point called as downcasting. Downcasting. So what is the point of downcasting? See here. So this is not possible, guys. So directly keeping parent object inside the child reference, parent object directly into child reference is not possible. You will get runtime exception. Some exception you will get. But here, one small point you have to remember again. With respect to this one again. What it is I'll ask you some things now. See here. So what is that point is? This is what child object. This is child object. And that child object you kept inside the, so you kept inside the where parent reference. So you kept the child object put inside the parent reference. Yes, this is allowed. In a universal point of view also, child can be referred by the parent point of view. So that's why parent reference holding the child object. That is okay. And there is no issue also. And you got the real object created for which class also you got in this line, in this case. So that means, let me do one thing. I will comment it down. Yeah, let me print the output first again one more time freshly. So you got parent reference level, internally it is pointed to which object, you got that information. Really it is pointed to the ICICI application. So that's why you got that class name here it is. The moment you are calling the get class. Now the point is, assume I have one more method here itself, public static void do bank operation, something like that. Do bank operation, something like that. Now observe here, I'm calling this method and I'm passing here and I'm taking here bank application. Okay, so what I'm taking here, bank application. And I'm calling this method now. From here, I'm calling this method. I'm calling this method and I'm passing this reference. Which reference? Bank application reference. Understand the point, guys. So, what's happened here? The scenario is from this main method, you are calling another method. And for that another method, it is always expecting bank application. So that's why you pass a bank application reference. But the bank application reference again internally pointed to a child class object, not its own class object. It's pointed to child class object. It's pointed to child class object. Now let's go to the child class object. I'll write some method here. Public void get bank name, something like that. String, whatever it is. Return bank name, something like that. So what's happened again here? The moment object came here, see here, I'm printing the app dot get. See, you are not able to access the get bank name of ICICI application. So there it is a public method only, get bank name, and it is an instance method, object method only. But why can't you access it? Why are you not able to access this method here? The reason is, again, when you come to the polymorphism point of view, I said one rule. So that's why, see how the things are correlated in Java language. Again, in the polymorphism point of view, I said one more thing. The moment parent referring child class, I said one rule very clearly. Method should be presented in parent class. That method should be presented in parent class. So that means the method, whatever you are trying to call, it should be presented in parent class. Sometimes it may be presented in child also. So the moment it is presented in child, priority given to the child. If no, not in child, then parent method is executed. That's what we discussed in the polymorphism, dynamic polymorphism point of view. Right? But in this case, what happened again, typecasting point of view, the getBank method available in the child class, but not in the parent class. If you go to the parent class, there is no method called as getBank name. It's available in the child class. So that's why you cannot access that method here it is. Why? Because internally, the object, whatever passed here, whatever the reference passed here, internally, this is having an object, the real object of ICICI application class. ICICI application class. So that means in reality that app, I mean whatever it is, the bank you passed as now app or whatever it is, simply nothing but app only. So app means application. So here the app reference variable method argument name pointed to this object. So data type is parent, but real object is child object. Real object is what? ICICI application object. So in this ICICI application point of view, you have a method called as getBank. So, and as part of our previous rule, what we remembered is the method should be, whenever you take in this rule, parent holding the child, parent reference child, I said method should be presented in the parent class. Then sometimes same method existed in the overriding in the child also. Then priority given to the child. In case there is no method in the not overridden in the child, then priority given to the parent. So that means 100% method should be existed in the parent. Now in this case, what happened? That getBank method is not available in the bank application. It's available only in the child point of view. Now what I have to do? So in this case, you have to do what you have to do is you have to do downcasting. So what is the point of downcasting is, again, the point of downcasting here it is converting, so I can say in English, in a simple point of view, extracting the real child or subclass of real child object to its own data type. Its own data type from parent reference. From parent reference. So that means what is the point of downcasting here? It is extracting the real child object to its own data type. Actually, it's available in the which data type? Parent data type. But internally, this is having again ICICI application object. So if you observe here, this app, a reference variable data type is what? Bank application. This is the data type it is having. But now what I'm trying to say here, it is downcasting point of view. I would like to bring, so this is holded this object, but it is in reality, it is ICICI Bank application. So now with respect to downcasting, what I'm trying to say here it is, so what the process of downcasting in this case is, what is the point of downcasting I'm trying to say here it is, so the process of assigning back the real object to real data type. So that means what is the actual data type? What is the actual Java class ICICI application? So that means I'm going to make like this. So I'm saying like ICICI application data type point of view, something like I'll take some variable name ICICI, whatever it is, equal to, I'm doing the typecasting here. So what is the real object you got? What is the reference you got? Reference data type bank application. So that means this is the reference. So that means, and you would like to convert it to ICICI application. So that means the targeted type is ICICI application. So what you have to do is the targeted type point of view parenthesis, and you will write ICICI application. And then why are you writing this ICICI application? You are converting that bank reference, that app reference, that app variable reference. So that means simply what you are doing, you are bringing out the real object. So in this case, this is what you are doing in this case. So what you are doing in this case, you are bringing out the real object, or you are assigning the real object to the real data type. Yes. Now what happened in this case? In earlier, app is the variable name or reference name pointed to a class reference called as bank application, but an actual object is created for the ICICI application. So now what you did in this case is, you are from that parent reference, from that parent's reference, you are converting to the again child reference. Simply what you are making in this case is, you are making parent reference to child reference. Parent reference to child reference. Now what will happen? Now finally what you got? This is the reference you got. In this case, ICICI app. So now ICICI app is the reference you got, and nothing but again in the memory point of view, this is pointed to same object only. Now understand, data type is same, object also same. In earlier case, data type is different, object is different. Now after doing the downcasting from parent reference to the real child data type point of view, so now this reference, whatever you have, belongs to same class, whatever ICICI application, even object also belongs to same class. So that means you have real object with respect to the same data type, now you can call the getBank method. So now see, that means what you are doing from this, what is the target, what internal it contains ICICI application. So that's why take the ICICI application reference, ICICI reference like ICICI. You can take any variable names, guys, ABC, XYZ, whatever it is, equal to the target type. What is the target type? So I'll take app here, app. So whatever it is, you can take a variable bank application or whatever it is. You can take application, whatever it is. So I take an application here, that's fine. But internally it contains which object, the real object belongs to which class, ICICI application. Same thing you are also taking here. So that means the destination, the target is ICICI application. So as part of my previous syntax, what I said, this is what target type. You have to follow again target type here. So what is the target type? ICICI application. Target is ICICI application. Now you can call the methods of ICICI application dot get bank name. So see here, now you are able to call the get bank name. So what you got? ICICI. So here you are achieving the abstraction. Here you are achieving abstraction also. How? In the bank application level, you got which object? In reality, ICICI application. So, but do you know by the time application point of view, what object came inside also, we are not sure about it. So that is all. So this is where generally people will do the typecasting with respect to references point of view. Parent can refer child object directly. There is no issue. It comes under the implicit. But when it comes to the explicit point of view or downcasting point of view, what you can do is you can only bring out or you can convert. Okay, you can point the real object data type to real reference, the real object data type to from the from the parent reference to the real child class reference level. You can do this type of casting. You can do this kind of casting. And then you can access automatically as now it's a same class object and you can call all the methods of that class like that. So this is what you can do with references. Simply what you are doing, parent reference, from the parent reference you are extracting or you are converting the target data type child class object. But internally it contains child object only. Don't say like sir, if it is having, for example, assume in this case, what I am doing is, just 1 second point of view. Let's see here. I take an object like this. Bank application equal to new bank application. So parent holding parent only. Okay, I'll take something like bank to whatever it is. Now what? Reference is same, object is same. The moment I created object here, what happened in the memory point of view? Object data type is same. Reference also same. What it is? Object data type is bank application. And reference also having bank application. So reference same, object to same. Then there is no point of typecasting. Parent referred by the parent itself. Myself referred by myself. So in the earlier case, what happened? Child object referred by the parent type. So then you can do this downcasting, like again targeted to the child only from the parent. So that means you are just bringing out, you are coming out from your parent reference to the real child data, child reference level. So, but in this case, it's typecasting. There is no typecasting concept because there is no, first of all, you are not connected child to parent or parent to child. So that's why if you see here, if I am passing this bank to until this, okay. But if you get, so what happened? In reality, this time, the moment I am calling this method, in reality, you have which object, guys? Not ICICI. You have direct bank application itself. So, but you are trying to convert the real bank ICICI application to ICICI application. How it is possible? Like you got an error, right? Same error we can expect again here. So, casting exception. So, blindly you can't do the casting from one data type to another data type. It's all about, only thing is parent can hold the child reference, and you can extract when the parent is really holding the child class object, then you can convert, you can extract the child object, or you can point that child object again back to the child reference level. It's not like direct object to object conversion, not possible, not possible. So in our previous case, what happened? Yeah, with this, what happened? Internally, it pointed to the real object of ICICI. That's why you are able to do. You are bringing out again ICICI to ICICI point of view from that parent reference. This is possible. Here, I mean, directly one object being converted to another object, ICICI to parent, bank to like object to object conversion is not possible. So these examples you have to practice, guys. Otherwise, you cannot remember all these things. Now, I'll ask one more question also. So we discussed, okay, let's take like this. I have one more class called as Axis application, Axis Bank application, which is inherited by the bank application only. So let's take like this, Axis Bank application. Okay, fine. And bank name is also Axis Bank, something like that. Now one parent have two child classes. One is ICICI, one is Axis. So go here. Now what I am doing here, it is Axis, yeah, bank application. So I'll not touch this example. I'll leave it as is. I'll take one more main method class, demo2, something like that, extended demo. So see here, what I will do, I'll remove all this. So I'll keep all this. I'll remove this. Okay. So understand here now. Bank application is having total two childs now. Okay, so I'm creating object of Axis Bank application, Axis equal to new Axis Bank application. Okay, fine. Now, as per my point, parent can hold the child, parent can refer child. Okay, fine. Now, based on that, I'm taking bank application, bank equal to, I'm not creating object for the same. I'm just holding like this. Yes, it's a value. Now, I'm calling a method called as do bank operations. And I'm passing the bank reference. Bank reference. So in this case, the moment you are passing the bank reference here, what happens? Internally, JVM jumps here and it will come here. Now, how do you know that? Now, how do you know that bank application reference, this bank application reference is pointed to ICICI application or Axis application? I can pass anything, right? Sometimes I can pass ICICI, sometimes I can pass Axis also. How can I identify it? Internally, the reference is holded which child object. When I have more than one, how do I know that? So let's see here. For example, I'm converting right now Axis Bank application, Axis equal to target type is again Axis application, and then fine Axis point of view, application point of view. This is what I said right now. Now sys out of Axis dot get bank name. So it will work now. Why? You are pointed Axis object to the parent, and you are done doing the same also. So you will not get any exception in this case. So you got Axis Bank. But assume some reason I assigned back here ICICI. So what I did, until this my rule is clear. Parent is holding child object. So it came here. By the time this time you got ICICI object, nothing but which class? ICICI application class. So that means the moment you got ICICI application, but you are trying to convert it to Axis Bank application. So that means another class. So internally it pointed to ICICI class object, but you are converting to the Axis application class. And there is no relation in between ICICI and Axis again. So what you are going to get? See, casting exception you will get, error you will get again. Why? What is the point of converting ICICI object to Axis Bank? In earlier, the moment you passed Axis, what happened? Here you have internally object of Axis application. So that's why you are able to do that, and you are able to see the output of Axis. But this time, the moment I passing one more child object, in this case ICICI point of view, internally it contains again what? This time ICICI as application. Then how you are going to achieve in this case extracting only ICICI application object, not from the Axis? How can you check that? Now this parent reference is holding which child class object? Tomorrow, not only ICICI, assume I have HDFC Bank application, third child class. Third child class. So HDFC application. So it's all about HDFC Bank. So all are extended 3. So that means total 3 classes available now. Then how do we know that? How can we do that? So that means now again my point of view, I have one more object called as. So these are all very, very important and it needs a lot of attention also. Okay, I will create object for HDFC application. And for this, you need to know again that polymorphism principles, what we discussed, all these things. And this is all real-time things also, guys. Don't think like simply we are discussing like that. It's a very, very important real-time things. Now, so in this case, what I can do? Parent can refer child. So that means I can pass ICICI, I can pass HDFC, I can pass Axis, anything I can pass, whatever I want. I can assign, I can send it to this method. But how do you know that? How can we identify parent coming up with child object? So in this case, my question is how to check parent holded which child reference? Which child reference? So if you know that, then based on that you will do the conversion. If you know ICICI, then you will do ICICI conversion and you will call ICICI bank name. If you know HDFC, then you will make HDFC conversion. If you know like that, if you know the thing, then you can do the conversion and you can call the method. But the problem here it is, how do we know that? Which child reference? So here we have to use one operator called as instance of operator. So when we discussed about operators, arithmetic operators, relational operators, logical operators, I said we have one operator called as instance of operator. Anyone remember that? I think you forgot. So see, we discussed this. So instance of operator. So first we can write if condition like instance of operator, and we can check instance of operator will always check that reference, okay, belongs to which class of. Exactly. It will check always with class name. Object class name is matching to the reference class name. Both are same, then it will give true. If not same, then it will false. So that means in this case, let's see here, I'm writing like this. If bank application instance of HDFC application, then else if application is instance of ICICI application, else if application is instance of access application. So if it is access application or else sys out of, you will say like out of choice, something, whatever it is. Nothing is matching. But now see here what I'm doing. I'm doing this thing. And here I'll do ICICI application, ICICI. ICICI. So this is how real-time things comes out in real-time applications. Now again, instance of what? So here I'll take HDFC application and convert it to HDFC application. And then I'll take it as HDFC to make it very clear. And then I'll make HDFC. Yeah, so now see here. So now what happened? You are passing what? ICICI. So that means in reality, the parent is holding ICICI application object. So it comes here. Application holded to which class object? ICICI. False. Comes here. True. So then conversion is happening and you are going to do all the operations of ICICI class methods you can execute. See? Dynamically. Now I will pass access. Now I will pass access. Now what will happen? Access means internally what object this contain this time? This one. So that means it comes here. It checks here. Application is the real object of HDFC application? No. False. Application reference. Reference is the real instance of ICICI application? False. Application is the real instance. That means real object of Axis Bank application class? Yes. True. That's why you are converted to Axis Bank application and you are calling the method. Now see, you will get the output as Axis. Now if I am passing again HDFC, then again same thing. It will come here. That means HDFC means what object? It is real object, this one. But hold it by the parent reference. Now parent came, see, parent is having 3 childs, guys. Simply in our terminology point of view, parent is having 3 childs. First time parent came with child number 1. Son number 1, son number 2, or something like that. First child, second child, something like that. So, and for example, assume your father is having 3 sons, and when you went to somewhere else, they will ask something like which son you are. First son, second son, third son. So based on that, I will give you the details. So if you said like, so you came up with so and so person's son, but the person again you have to prove like you are the person of, I mean you are the first person or second person or the specific person point of view. So same point of view. Now it is all HDFC application. So application is the real object of HDFC application. Yes. So then you return logic like conversion to HDFC and calling HDFC class methods. So here in this case, you are taking again help of instance of to identify what is the real object. So this is how the typecasting and all this, okay, dynamic typecasting point of view are to identify which data object, which child object is holded by the parent when you are having more childs for a parent point of view. So whenever you are doing this kind of things, this is what you have to follow all these things, typecasting, all these things. So this is what comes under the polymorphism, abstraction and everything, guys. So you see, if you observe here, abstraction says what? Hiding the implementation, showing the features. So here, and polymorphism. What is the polymorphism is saying? One object acting in multiple ways. See, it looks like always one object, but different behaviors. Sometimes it is coming up with HDFC application object, HDFC activities. Coming up with ICICI Bank application, ICICI activities. Coming up with Axis, Axis activities. So looks like one object, but doing multiple things. This comes under the polymorphism point of view. So we are achieving polymorphism in this case, this point of view. So that's all about today's typecasting. It's important and it's a real-time thing and it's a little bit, you need to focus more also. Primitives point of view, it is very straightforward. only non-references point of view, you have to remember all these points. What and all you can do, what you cannot do. Please practice these 2-3 examples what we discussed, then you will get more idea. Okay, so that's all for today. And tomorrow I'll start the concept of exception handling. So I'll start the concept of exception handling. So it's a now we are moving to the new concept called as exception handling. So what is an exception handling and all we'll see. Or else we can see static methods, whatever it is. Tomorrow, based on our discussion, I'll take these things. I'll decide out of these 4 what we can discuss tomorrow. I think probably I'll discuss tomorrow static and default methods in the interfaces like that. We will see. But tomorrow a new concept I'll start. Out of this one, I'll make one thing as a priority. I think probably I'll go with this one only. So it's better to go with this one. We will see that. Okay, so that's all for today. Let's connect on tomorrow with new concept. If you have any doubts, you can ask.